of zeros of a quadratic function. Zeros, or roots, are the x values where f of x equal to 0. You found that by solving the equation in the general form, setting it equal to 0. Then from here, you use the different methods: factoring, quadratic formula, graphing. We have already covered factoring, so now let's look at using the quadratic formula. Now, let's look at an example using the quadratic formula. It's used when factoring is difficult. Here is the formula, and it is usually given in a math formula booklet for a standardized test, exam, or given by your teacher for a summative or an assessment. So let's look at the example. We're going to solve 2x squared plus 5x minus 3 equals to 0. First, we need to identify a, b, and c of the quadratic equation. In this particular equation, a equals to 2, b equals to 5, and c equals to -3. Now we will substitute the following into the given formula. Notice I kept the same colors of the coefficients that were stated and used them in the formula to substitute. So now we have -5 plus or minus the square root of 5 squared minus 4 times 2 minus 3 divided by 2 times 2. Now we take care of what's underneath the square root first. So we still have -5 plus or minus the square root of 49 divided by 4. We simplify the square root of 49, which becomes 7, and are left with -5 plus or minus 7 divided by 4. Now we are going to separate this into two separate equations, because the plus or minus means we're going to add the 7 and then we will subtract the 7, hence giving us two different values for our x's. So first we will add the 7, so -5 plus 7 divided by 4. Then next we will subtract the 7, so -5 minus 7 divided by 4. Now for x1, we get 2 over 4. We simplify the ratio, and it's 1 over 2. For x2, we receive -12 over 4, which equals to -3. So therefore, we have the solution for this particular quadratic equation. So x1 equals to 1 over 2, or 0.5, and x2 equals to -3. Great job. Now, if you are using the TI-84 Plus, here are the steps that you will use on your home screen. Now, those of you who always wanted to use the fraction function, it starts off with alpha and then xt theta n. That will give you your fraction format for your equation. So follow these steps and you will basically input this on your home screen and receive your answer. Notice our answer is correct. It's 1 over 2 for the first one. Now, without clearing your screen, I am just going to copy the equation above and then place it again into the calculator and change my plus to a minus. And in this case, you will see both equations on your screen, and notice that our answer is -3. So remember, for my advanced students, if you are doing this in your calculator, you could just place it on your home screen and follow these directions. Graphing quadratic functions. The graph of a quadratic function is a parabola. We're going to graph f of x equals to x squared minus 4x plus 3. First, we need to determine whether it is going to be upward or open downward. If a is greater than 0, then it's opening upward. If it's less than 0, then it's opening downward. In this case, a equals to 1, so it should open upward. However, there are key points we need in order to create this graph. The first key point is our y-intercept. The y-intercept in this case equals to 0, 3. Next, we have our x-intercepts, or what we call our zeros or roots. In this case, we have 1, 0, and 3, 0. Now, last but not least, we have our vertex point, which is our minimum value. So our minimum point here is our vertex is 2, negative 1. And once we have those particular points, we draw our parabola. Great job. Axis of symmetry. This is the vertical line that divides the parabola into two equal halves. The formula that is given is x equals to opposite b divided by 2 times a. I say opposite b because we're taking the opposite of whatever value b is, meaning if it is negative, it becomes positive, and if it's positive, it becomes negative. Now let's look at an example. We're going to find the axis of symmetry for f of x equals to x squared minus 4x plus 3. First, let's identify a and b in the given quadratic function. So for this particular example, a equals to 1 and b equals to negative 4. Now we're going to take these values and substitute it into the given formula. Notice I use the same colors for identifying a and b within the formula that was given. So now we have opposite of negative 4 divided by 2 times negative 1. When we simplify it, we get x equals to 2. So now you know what the axis of symmetry is. Now on our graph, how do we identify or display this? You already have your parabola from graphing. What you're going to do is have a dashed line where x equals to 2 and just identify it, showing that this is where the axis of symmetry is. Great job. Vertex of a parabola. This is where the turning point is located of a parabola. It's either the minimum point if a is greater than 0 or maximum point if a is less than 0. Now what we're going to do is actually find the coordinates for this particular vertex. We are using the formula for axis of symmetry, what we just learned. So opposite of b over 2 times a, then we're going to take that answer or the value of x and substitute it back into the function and find the value for y. So let's look at an example. We're going to find the vertex of f of x equals to x squared minus 4x plus 3. First, we identify our a and b in the given quadratic function. A equals to 1 and b equals to negative 4. We will take these values and substitute it into the x value for the formula. In this case, we have x equals to 2. Now that we know what x is, we are going to substitute it back into the function that was given So wherever we see x, we are going to substitute the value of 2 where it is. Now when we simplify, we have f of 2 equals to -1. Therefore, our vertex is 2, -1. I hope that helps. Finding the minimum or maximum value for a quadratic function. First, we need to determine if a is greater than 0 or less than 0. If it's greater than 0, the vertex point is a minimum point. If a is less than 0, the vertex point is a maximum point. So let's look at an example to determine how do we find this. For this example, it says find the minimum of f of x equals to x squared minus 4x plus 5. We looked up in this case because it tells us it's a minimum point. However, let's still go through the steps to determine what a equals to. So a equals to 1, therefore the vertex has the minimum point. So we just identified and made sure that that was not a typo. Next, we're going to identify our b because we need what the b value is in order to find our vertex point. So b equals to -4 for this quadratic function. Next, we're going to use a vertex formula that includes opposite b over 2 times a for our x value. And in order to find our y, we're going to substitute the x value back into the equation that was given. So remember, to find our x, we have opposite b over 2 times a. We substitute in the values that we identified and simplify. So in this case, x equals to 2. Now, for our given function, we are going to substitute in 2 wherever we see x. So now that we have substituted in the 2, we're going to simplify, and f of 2 equals to 1. So this gives us the vertex is 2, 1. How do we determine the minimum value in this case? The minimum value is your y coordinate. So therefore, the minimum point equals to 1. Now let's look at a practical application. This is projectile motion. So here we have the height of an object is given as h of t equals to -16t squared plus vt plus h naught. T is your time. V is your initial velocity, and h naught is the initial height. So let's look at an example. We have a ball is thrown upward at 40 feet per second from 5 feet high. Notice, once again, I color coordinated the values to match what is given in our initial statement. So here, upward at 40 seconds per feet is our initial velocity. 5 feet high is our initial height. So all we're doing is writing out how this equation would look like. So what do? I just simply substitute in the values for v, which is the initial velocity, and h naught, which is the initial height. And when I do so, I have the function h of t equals to -16t squared plus 40t plus 5. Let's recap the steps for analyzing quadratic functions. First, you always need to identify your a, b, and c of your quadratic function. You can find the axis of symmetry and the vertex. You can calculate your y-intercept. Find your zeros if possible. Plot points and sketch the graph. This has all been covered in today's lesson with all about quadratics. Thank you for joining Dar's Academy, and we will see you next Saturday. Take care. Goodbye. Now here's a recap of using your TI-84 Plus for quadratic functions. If you want to see the graph, you press y equals and enter the function. Here I have an example of f of x equals to x squared minus 4x plus 3. You could press your window to set the viewing window to make sure you can see the graph in its entirety. You press graph to see the parabola, and you can trace or calc to find your zeros. You can also use calc for your minimum or maximum for the vertex, and you can also trace to find your y-intercept. So becoming more familiar with your calculator will give you the option of actually making sure that you have correctly answered the full question. Now let's review and look at the key takeaways for this lesson. For quadratic functions, you have a standard form or a general form. That is f of x equals to ax squared plus bx plus c. Factoring and expanding are inverse operations. Your zeros can be found by factoring or using the quadratic formula. The vertex formula is given, and it uses the formula for the axis of symmetry. Graphing requires your key points. Remember, your y-intercept, your zeros, our roots, our x-intercepts, and of course your vertex. How can you actually look at these particular things on a graph? You could use your TI-84 Plus, your GeoGebra website, or go to Desmos. They are definitely powerful tools to use to analyze a quadratic function. I hope you enjoyed the lesson. I'll see you next week.